Hi everyone, I am Whit Roy. Welcome to this audiobook learning video.
Hi everyone, my name is John and I work alongside Whit Roy as an electrical tutor.
In this video, we will introduce ASNZS 3017, which covers electrical installations, verification by inspection and testing. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 3017-2022. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for the EWRB exam. The official standard is the legal and technical reference. If there is any difference, missing detail, or possible mistake in this audiobook, you must follow the official document. What this audiobook does is take the key ideas from the standard and explain them in simple spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real electrical work. So please think of this audiobook as a learning companion, not a replacement for the actual standard. All right, let's get started.
Section 3. Visual Inspection. Section 3 is about visual inspection. Before we start using test instruments, we must first look carefully at the electrical installation. Visual inspection is a very important part of verification. Many problems can be found by looking before testing begins. For example, we may see damaged insulation, missing covers, poor support, incorrect labelling, unsuitable equipment, loose fittings, exposed conductive parts, or equipment installed in the wrong location. Testing is important, but testing alone is not enough. A test instrument may give a good result, but the installation may still have a visible problem. So the simple message is this: look first, then test. Visual inspection helps confirm that the work has been completed properly, the correct equipment has been used, and the installation is suitable before it is placed in service. Clause 3.1 General. Clause 3.1 explains when visual inspection is required. A visual inspection must be done when work on an electrical installation has been completed. The purpose is to verify that the work complies with the applicable requirements. In simple terms, after electrical work is finished, we do not just energize it straight away. We first inspect the work to check whether it looks correct, safe, and complete. The visual inspection must be carried out before testing or at the same time as testing. Where practicable, the visual inspection should be completed before that part of the installation is placed in service. This is important because once an installation is energized, some risks may increase. It is better to find visible defects before supply is connected. The clause also reminds us that some parts of an installation may not be visible after the work is finished. For example, cables may be hidden inside walls, under floors, in roof spaces, in concrete, or underground. If a part of the installation cannot be inspected at completion, then it should be inspected during the installation work, before it becomes covered or enclosed. In simple terms, do not wait until the end if the work will be hidden later. Inspect it while you can still see it. Clause 3.2 Safety Requirements before visual inspection. Clause 3.2 explains the safety requirements before visual inspection starts. Before carrying out the inspection, a risk assessment must be done. The purpose of the risk assessment is to identify hazards and risks. It also helps decide what controls are needed before the inspection starts. The risk assessment should identify whether suitable PPE is needed. PPE means personal protective equipment. For example, depending on the site, this may include safety glasses, gloves, protective clothing, safety footwear, or other required protection. The risk assessment should also identify what equipment is needed for the inspection. This may include a torch, access equipment, barriers, signs, test equipment, or other tools needed to inspect safely. The risk assessment should also consider safe access. This is important because visual inspection may involve switchboards, roof spaces, ladders, ceiling areas, underfloor areas, plant rooms, outdoor areas, or other locations where access may create extra risk. ASNZS 4836 gives further guidance for safe work. In simple terms, visual inspection is not just looking. You still need to plan the work safely, choose suitable PPE, use suitable equipment, and make sure the work area can be accessed safely. Clause 3.3 Checklist. Clause 3.3 gives a guide to the matters that should be checked during visual inspection. The checklist is representative. This means it gives important examples, but it is not limited to only those items. The actual inspection must suit the installation, the work carried out, and the applicable requirements. First, the general safety items need to be checked. Basic protection should be checked. Basic protection means protection against direct contact with live parts. In simple terms, live parts should not be accessible where they can be touched. This may involve insulation, covers, barriers, or enclosures. Fault protection should also be checked. Fault protection means protection against indirect contact with exposed conductive parts if a fault occurs. Examples include automatic disconnection of supply, double insulation, or an isolating transformer. In simple terms, if a fault makes a metal part live, the installation must have a method to protect people. Protection against hazardous parts should also be checked. This includes protection by enclosures, guarding, or screening. It may involve parts that are hot, parts that could cause physical injury, or areas where flammable material could be affected. Protection against spread of fire should also be checked. For example, where wiring passes through a fire barrier, the fire protection must not be weakened. The general condition of electrical equipment must also be checked. Look for signs of damage that could affect safe operation. Also check that unused electrical equipment has been properly disconnected where required. In simple terms, the general inspection asks, is the installation safe to touch, safe under fault conditions, protected from hazards, protected against fire spread, and in good condition? For consumer mains, the conductors must be clearly identified to show their intended function. In simple terms, we need to know which conductor is active, neutral, earth, or other required function. The installation wiring system condition must also be checked. For underground systems, check items such as enclosure, depth of burial, and mechanical protection. For aerial systems, check items such as mechanical protection, support systems, and whether cables are likely to be disturbed. The connection of wiring must be checked. Protection against external influences must be checked. The arrangement of the consumer mains must also be checked. In simple terms, consumer mains are important because they are close to the supply side of the installation, so identification, protection, connection, and arrangement must be correct. For switchboards, the location must be checked. This includes access and egress. In simple terms, people need to be able to get to and away from the switchboard safely. Protective devices must be checked. This includes the selection and setting of adjustable protective devices. The check should consider overcurrent protection, arc fault protection, and discrimination requirements where applicable. Isolating devices must be checked. This includes main switches. Connecting devices must be checked. Examples include neutral bars, earth bars, and active links. The connection and fixing of wiring and switchgear must be checked. Identification and labeling of electrical equipment must be checked. Protection against external influences must be checked. The construction of the switchboard should be checked against the applicable standards. The correct RCDs must also be checked, or the correct alternative protection method where allowed. In simple terms, a switchboard inspection asks, is it in the right place, safely accessible, correctly built, correctly labelled, correctly protected, and correctly connected? For wiring systems, conductor size must be checked in relation to the protective devices. In simple terms, the cable size and protective device must work together. The cable cores must be identified correctly. The wiring must have adequate support and fixing. Connections and enclosures must be checked. Particular installation conditions must be checked. This may include underground wiring, aerial wiring, and safety services. Segregation from other services and other electrical installations must be checked. Protection against external influences must be checked, including the use of suitable enclosures where required. In simple terms, wiring systems must be the right type, the right size, correctly identified, properly supported, correctly protected, and suitable for the environment. For electrical equipment, isolation and switching devices must be checked where they are needed for protection against injury from mechanical movement. This can apply to motors and other equipment with moving parts. Isolation and switching devices must also be checked where they are needed for protection against thermal effects. This can apply to motors, room heaters, water heaters, and similar equipment. Switching devices for particular equipment must also be checked. Examples include socket outlets and water heaters. Particular installation conditions must be considered. This may include locations affected by water, explosive atmospheres, extra low voltage systems, and high voltage situations. Equipment should also conform with the applicable standards and any additional manufacturer's instructions. Connection, support, and fixing must be checked. Protection against external influences must be checked, including ingress of moisture and required IP rating where applicable. The equipment must also be suitable for the intended voltage, current, and frequency. In simple terms, electrical equipment must be suitable for the job, suitable for the location, correctly connected, correctly fixed, and protected against the conditions around it. For earthing, the MEN connection must be checked where the installation uses an MEN or TNCS system. The earth electrode must be checked. Earthing conductors must be checked, including size and identification. Equipotential bonding conductors must be checked, including size and identification. Connections, joints, and terminations must be checked. Protection against external influences must be checked. Connections to earthing arrangements for other systems must also be checked where applicable. The inspection must also consider whether an earthed situation has been created that may require additional electrical equipment to be earthed. In simple terms, earthing inspection is not only checking for a green and yellow conductor, it is checking that the whole earthing and bonding arrangement is correct, continuous, identified, connected, and suitable for the installation. So, Section 3 gives us a very important reminder. Before using test instruments, we must look carefully. A good electrician does not rely on testing only. A good electrician inspects first, finds visible problems early, controls the safety risks, and then carries out the required tests.